Okay, so yes, question.
So, do we, like, Monday, do we need to bring in our work that we did?
You may,
And show
if you had a question about something you wanted me to look at, but you do not have to.
Okay.
Yes.
For last week's class, or
What?
next week?
Well, this is what you see there on the board is this week. Okay. Now, here is next week.
Review.
And test.
Saturday.
Review, test. Okay.
Is it still in
The test promptly begins at 1, so you need to be there like 12:45 or earlier, because I've got 3 classes that I'm gonna have to administratively get the test out to, and I'm required to check IDs for the final. So bring an ID, preferably a WSU ID. If you don't have your WSU ID, make sure you know your student ID number. And then also bring something like a driver's license. What?
So for the test, how many, do you know how many points and questions it is? Is it like a test?
Yes, as a matter of fact, I do. There will be 32 questions, 4 points each, that's 128 gradable values.
So if we get it.
There is no curving on this one like I've done. No, it's partial credit, just like I have done.
Don't have to get it.
I was instrumental in getting that 4-point partial credit system that we used on the first 4 exams.
So how does that work with our short work?
Wow, oh, timeout. I'm talking about, are you talking about exam 5 or the final? Okay, I'm talking about the final. The final is, exam 5, I don't remember how many problems are on it. I just have to look it up.
I think Alex said like 37 or something.
That sounds about right. I know it's less than 40. Generally speaking, the more problems there are within reason, the better your chances for a grade. Because, and any of them you miss count less. The computer will give some partial credit if there are multiple parts in a problem. Okay, But in terms of giving the partial credit like I do, the answer would be no. Other questions? Yes,
For the final, is it still at Hubbard Hall?
no. Oh, wait, Hubbard, yes. It is in room 218 of Hubbard Hall.
I don't know where that is. I'm gonna get lost.
It's next to the husband.
I have no idea where that is.
Just Google it, it'll take you there.
I've tried that before and I would, the whole.
Do you know where that big dorm right in the middle of campus is?
I don't ever go on there.
It took up half of Coke Arena parking spaces.
Okay, North
Yeah.
Carolina.
Yeah, well, that big dormitory that's right there is directly to the east of that,
Okay.
You said 217.
218. It's a big auditorium type room.
And we have to.
What I'm tentatively going to do is I'm probably gonna put my college algebra class on the front row, because it's small. And then I'm gonna have probably you guys, I may have sit in the back however many rows, and then have my online in the middle however many rows. Okay, so that's generally what I plan on doing. I haven't been in that particular room in a while, so I don't know exactly how many rows it has and how many seats are per rows. I've got to do the math.
We'll figure it
So
out.
where should we park?
At the stadium.
Anywhere but.
Okay, time out. Don't answer that question. Look at my notes in Blackboard. I have made 2 or 3 announcements in Blackboard to give you those kinds of information. What?
You have to register this. I won't know.
No, no.
No, just- okay.
The only people who have to register are the people who go to, for example, the testing center, if they have disability rating where they get extra time, or the people who have in my online class who might live in Salina or Kansas City and have to have remote proctoring and that sort of a thing. And that doesn't apply to you guys at all. Any more questions? All right. Well, that said, let's go ahead and get started. Well, I think I'm starting to warm up enough that I can take this off, hopefully. I thought this was kind of a fitting jacket to wear to WSU. I could have gotten a black and red or black and blue just as easy. Then I've got enough bruises anyhow.
Ooh. That was bad.
Yeah, it was bad. Most of my jokes are, as you found out. I haven't told nearly as many jokes this year as I ordinarily. Thank you. The midpoint formula. This is not the first time you've seen this. Although it was tested in exam 1. So if you go back and look at the test questions in exam 1, that would be real good review for this, because I'm not doing citations on this online test. Okay. So the midpoint formula. The midpoint formula is unique. Or as you used to probably say the first time you saw it, unique. It is the only one where you have this x1, x2, x sub 1, x sub 2 business, where you add instead of subtract. It is the only one, because what you are doing is you are adding two items and dividing them by 2, which is nothing more than averaging the two sets of x values for the beginning and the end of the line. Okay? Likewise, for the y values, you're taking the y value of the first of one end and the y value of the other end. You're adding them, dividing by 2, or averaging them, finding them halfway. And that's what it is. That's all this formula is. It's averaging the two x values and averaging the two y values and putting it in point form. Okay. Okay, here we are basically, I typed in there what I just told you. Here's an example. Okay. And I need to turn on this light for the sake of the video. Again, here is the formula. This one's just a theoretical problem. You take the x value of this one, you take the x value of that one, you add them, divide them by 2. Likewise with the y's. Well, now let's look at some real numbers. They wouldn't just throw nice numbers in there to start with. Okay. They're calling this 0.1 and that 0.2. So they're taking the x value here and the x value here, and they're going to add them and divide them by 2. Okay. If you add these two and divide them by 2, you get 1.35. Do I need to put in the arithmetic between those two steps for you? I don't remember whether I told you this, but when I used to teach adding and subtracting decimals to 6th and 7th graders, I made up a thing about it being like the Old West in Dodge City. You see, back in the Old West of Dodge City, wranglers would drive cattle from Texas up to Kansas. And while they were doing that, driving them cattle, they'd swing them lariats, and they'd say, round them up, line them up, bring them on in, yeehaw! Well, do you know what? Adding decimals is the same thing. I got these two here decimals. I'm going to line up my decimal points. Now, I don't need to round them out because they're already the same length. But if there were a 5 here, I'd have to put a 0 there to round them out so they're the same. Well, all that's left to do is bring them on down. Bring them on in. In this case, we're subtracting, not adding. 15 minus 8 is 7. Okay. And 4, we borrowed 1 from this, so 3 minus 1 is 2. Okay. Now, that means we got 2.7 divided by 2. If you need to go over here to some scratch paper, the decimal's already at the far right on this one, so we just bring it up, and we use that 4-step method of dividing. Estimate, multiply, subtract. Do it again. Well, 2 goes into 2 once. Bring down to 7. I left out bring down in my list. 2 goes into 7 3 times. Okay, which gives me 6. 1 remainder. I stick an extra 0 on there and it's behind the decimal so you can, and 2 goes into 10.5. And that's where that 1.35 came from. And you can do the other one the same way. Okay. Now, if you converted this to fractions, okay, technically this is -1 and 8/10. 10 times 1 is 10 plus the 8 makes 18/10 plus this is 4.5 or 5/10 if you please. This is 4 and 5/10. So 10 times 4 is 40 plus 5 is 45/10. I have a common denominator here so I can add or subtract in the case. And I get 27/10. Okay. Now, I've got to take this 27/10 and divide it by 2/1 for this. How do you divide? Well, you flip and multiply. 27/10 times 1/2 equals 27/20, and that's how they got that. Okay, I'm not going to do the lines. Okay. Well, I hope you enjoyed my little Kansas history lesson. So what do? You line them up, you round them out, you bring them on in. Yeehaw. That might be useful to you as a parent. Okay. I also have one made up for multiplying decimals as well. Okay, here we go. This one I was showing you. Now they finally get around to these. Okay, so what are we going to do? We're going to add that -4 and this 8 together, divide them by 2. We're going to add this 6 and that 1 together, divide them by 2. Like so. Simplify it. And this whole thing simplifies to 2. And that simplifies to 7/2. So that is the point that is halfway. They never did draw the picture on this one. Okay. But that's the point that's the midpoint of those. Remember, 7/2 is really 3.5. Another decimal. Boo yes. Okay, here we go. You get that. If you tried to graph that, that'd be approximately -4, that'd be approximately -1 for graphing. Because you can't be that accurate otherwise. Okay, a little bit of geometry thrown in. These are points on the end of the diameter of a circle. There. That one's not bad.
Hey, that was actually pretty damn good.
Okay. 4/1 over 4 and up 1. Okay. and -2 and 3. Whoops, -2 and 3. Well, that doesn't exactly work. Oh, okay. That must be. That doesn't much look like a diameter. Obviously, this circle isn't centered on the axis. So anyway, what they're saying in here, let me get rid of this axis because that's confusing me. I've got 2 points. This one's going to be at about this level. Well, actually, probably about there. This one's going to be about here. And it's going to be this diameter. And the question is, what is the value of the center of that? Supposedly, that's a diameter and goes perfectly across the middle, if drawn in a perfect world. Well, we just got to do the arithmetic. Well, there it is, actually. Well, I wasn't too far off on my guess. Oh, well. And I wasted one of my best ever drawn circles. Okay, so there's the real thing, and we want to know where that is. So here are my 2 points, point 1 and point 2. And we, like I said, we can just arbitrarily choose which one to be whichever, it doesn't matter. As long as we're consistent after that. Okay, here's the formula. We put in the values, the -2 and the 4 over 2, the 3 and the 1 over 2 for the y values. We simplify this and we get the point 1, 2. This slide is out of sequence because I haven't taught you how to do the equation of a circle yet, supposedly. So I'm just going to skip that one. What they're doing here, actually, I will show you this. This is the distance formula, which we'll go over in just a moment. Patient guide says I'm going to do midpoint before I do distance, but to me it makes more sense to do distance first, like I did in chapter 1. Okay, well anyway, here is the distance formula. Notice the minuses now. Okay. What they're doing is they've got these 2 endpoints. For the circle formula looks like this. Well, this is the radius from here to here. Okay. We know that this is the midpoint, but we don't know this length. So what they're doing with this distance formula right here is they are finding the length of so they found out that the length of this thing is the square root of 10. Well, that's kind of hard to grasp. Not really. It's a little bit more than 3. Square root of 9 is 3, right? So square root of 10 is just a little bit more than 3. So that's how you can guesstimate square root distances. Okay, actually that's called interpolation. Now, so if we figure this out, let's call it 3.1. I don't know if that's exactly what it is, but we can call it that. Okay, because you guys don't get to use a calculator to find out for absolute. Now, given this information, we can find the formula of that circle. This H is the opposite X value of the center. This K is the Y value of the center. Okay? So, what are we saying this part up here is? Well, this is X minus 1 squared plus Y minus 2 squared equals 3.1 squared, or square root of 10.
That would be just 10, right?
Oh, wait a minute, this is the length of that, that's R. So actually, we don't even have to do that. If R equals square root of 10, then R squared equals 10. And there's our formula. Okay? And again, this slide is kind of jumped in there out of order. They're just doing what I just showed you. The distance formula. They tie it in, the distance formula is tied in with the Pythagorean theorem. You know, the Pythagorean theorem, we did some problems with how tall is the tree earlier. That was the Pythagorean. A squared plus B squared equals C squared, where C is always the hypotenuse or the long side of the triangle, and the other two are at a right angle to each other. Well, this and this are just two forms of the same thing. All I did was take the square root of both sides. But why didn't I use the plus or minus? I only used the plus because distance is always a plus. Okay. So this is the Pythagorean theorem. This is basically a variation of the formula for the distance formula. Because this, if you take the two X values, it tells you basically how long the X is, and same with the Y's, is basically what that does. Okay, the distance between the Y's, the distance between the X's correspond to this A squared and this B squared. And the D is the equivalent of the C. Okay, now, doing that, we got these 2 points. Doesn't really matter which one you call point 1 or point 2. As long as you stick with that after you do it. Okay, I always choose the way the numbers are easiest for adding and subtracting. Well, anyway, here we go. We're going to put the 2 in here. Right there, that -2 and the +4. They call this point 2, they call this point 1. Now, this is just something I like to do. Okay, nothing required about this. When I've got my 2 points listed like this, I generally will call this one 0.2 and 0.1. That way I can go left, right, left, right. And it's less likely to make a mistake. Okay? Just my own personal thoughts. Watch out for double negatives. Okay? They love to trip you up. And we get 6 squared plus -4 squared. 6 squared is 36. -4 squared is 16. So 36 plus 16. Square root of 52. Square root of 52 is 4 times 13, just like a deck of cards. 52 pickup. 4 suits of 13 each. You can extract the 4, so you get 2 times square root of 13. Well, how big is 13, square root of 13 for the sake of graphing? What perfect squares is it between? It's between 9 and 16, 3 and 4. And it's just about halfway, maybe slightly more than halfway. So as an estimate, I would call it 3.6. Okay? So that's how long this would be. Well, actually it's 7.21. They figured it out for me. Okay. Yeah,
Probably.
most likely.
Yeah, that would be 3.6 times 2.
True.
How much faster are we gonna be able to do that?
Yeah, 3.6 times 2 is about 7.2. Almost exactly. So I was real close. What was your question?
The test, are you gonna want us to try to guess the decimal
No.
or?
Right here is good enough. But you do need to bring it down to this step. Okay, here's another one. They're just warning you with the green that we had minus a negative in there and minus a negative in here. Okay. 0 minus -3. Now see if I put excuse me, 0 minus -4. If I put the -4 here and that -3, I'll get it right in a minute. If I put the -3 in front and I put the -4 in front, then I could go left or right and I wouldn't have to think. Still might have a double negative. That wouldn't necessarily stop that. Again, here, this is really still the same problem. Okay, now we got one with decimals. Okay. Well, here they're just telling us we have minus a negative. This plus that makes 5. So you have 5 to the second. This plus this makes -3. So you got -3 to the second. 5 to the second is 25. And 3 to the second is 9. Okay, that's where that came from. And then 34 is just a little less than 36, 6 squared. So that means this is going to be a little less than 6. Okay. Now they're getting real nasty. Well, you still work it the same way. And if you're lucky, that some of the radicals might disappear when you square them. Okay. This is a radical 3, that's a radical 3, so I can add this -1 of them and this +6 of them together, which gives me +5 radical 3s. Likewise, over here, I've got the same radical, so I can combine these. That's a -1 represented there. So I'm going to get just radical 6. And I have to square them both. Well, when I square this, 5 squared is 25 times 3, because square root of 3 squared is 3. And this is just 6. Okay, and 25 times 3 is the 75 you see here. And that one comes out a perfect square. So that one's kind of nice. Can I erase my scribbles? Here's another one. Nice spacing there. Fix that. That's not tolerable. Yeah. Don't forget to save it, right? Okay, now we're good to go again, or better, fine. Okay, here we got these. And it simplifies some. And again, 89 is somewhere between 81 and 100. A little less than halfway. Questions on finding distance? Okay, and there's a graph of that particular problem. So if you took a ruler and measured this diagonal line, it should come out a little over 9, whatever, centimeters, inches, whatever kind of units you had. Circles. Oops, went too fast. Okay, this is just some language. Equidistant. They are always the length of the radius distance. Okay. Remember the example I told you about the ancient Egyptians? Drove a stake in the ground, tied a long rope on it, swung a big circle, made 2 sets of parallel signs, and that was the foundation for their pyramid. Okay. Well, always equidistant, that from the stake to the end of the circle or the end of the rope. Now, why do they have this disclaimer here? That means the radius has to be some number bigger than 0, a positive number. Okay, there's the standard form. I showed it to you a few minutes ago. The H and K opposite of sign, and the R for the radius. Okay, and the radius has to be positive. Okay. If on a test they were to give you something like this, what would you know about that? It is not a circle, it is undefined, because the radius has to be positive. A positive counting number. It can't even be 0. If it's 0, it's just 1 point. Yeah. So in one sense, that negative out there is kind of like a negative log value. Okay, here we go. Graph a circle with center of this and radius of that. Take that, opposite of sine, take that, opposite of sine, take that and square it. Done. The only hard part of this is you got to memorize that formula. Okay, now, here's how you graph one. Now, when you get ready to graph these in ALEX and on your ALEX test, always use the magnifier to blow it up as big as you can for accurate placement of the point. Okay? Because they love to play games with you and think if you're trying to put this point and you're off just a little hair from that perfect place, then they're going to zap you.
There's no margin.
They're not numbered, they have just graph paper. And you have to locate the point on the graph paper. Okay? So you absolutely want to use the magnifier so you can get your point placement as accurate as possible. Okay? Both your distance of the radius and your center. Now, back to this. Here's the value of the center, -3,2. We've determined that the radius is 4 because in the formula, this is r squared. So square root of 16 is 4. So going from the center, we go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, because by definition, these points are equidistant from the center. And then we just try to draw in the circle and hopefully we get it pretty. I wasn't kidding you guys when I told you that was one of the best circles I ever did. Usually mine look like goose eggs. Okay, so that's the process of graphing. Here's another one. This is the kind of thing that they'll give you. What is the center? Well, it tells you. What is the radius? Oh, be careful. This isn't an r squared this time. This is the actual radius. We can graph this circle without even writing the formula. Okay? Except it tells us we got to. You got to read the directions. So we got to do two things on this. We got to graph it. We got to write the equation. Well, we can graph it real easy, but let's write the equation first. We got this, and we got that, and we square that. You know the biggest problem that students make on this problem? They forget to square this. They forget that that's r squared. Okay? Now, we got some simplifying to do here. We don't need to show this -0. So we can simplify this to just look like that. Now, the hidden message is, if you ever do see a plane x squared or a plane y squared, that means there's a hidden -0. Okay? For one of the two coordinates. Okay, now we're ready to graph this thing. Our center, right here, 0, -3. Our radius is 2, 1, 2, 1, 2, 1, 2, 1, 2. And then we draw the circle. So we've completed both of the requirements of this problem. Any questions on this one before I go forward? Look like you might have a question. Are you talking about this point or those points? These 4 right here. The radius is 2. I drive a stake here at the center. I stretch out a 2-foot-long rope. And I go, boom, boom. I mean, that's if you had a rope. But when you don't have a rope, you just count over 1, 2, You figure that one's gotta be on the circle. Up 1, 2, down 1, 2, and left 1, 2. You hit the 4 corners. You can't get these because these are all decimal values. Okay? Functions of pi. The rounder. But based on these, you can make it as round as you possibly can. I can't even follow theirs and make the circle right. Did I answer your question or not? Okay. Okay, here's another one. You do this one. Put that calculator away. Okay. By the way, during the final, you will not be allowed to have your phones anywhere in evidence. And they need to be silenced as well. And, oh, on the cruder side of things, I will allow